This will be for the con assignment, number of solutions of quadratic equations. So a quadratic equation is of the form ax squared plus bx plus c, okay? And really it is y equals that value. And when you solve a quadratic equation, the first step is always to set it equal to 0. All right, so we learned that the quadratic formula is negative b plus or minus radical b squared minus 4ac all over 2a. Okay, this part of the quadratic formula, the part that is under the square root, is what determines how many solutions the quadratic equation has. So b squared minus 4ac is called the discriminant. Okay, it tells us the number of times the parabola crosses the x-axis. So I'll show you those graphs, but as we know, this equation right here, when you graph it, it's going to be a parabola. All right, so b squared minus 4ac is your discriminant. If the discriminant is positive, the parabola crosses the x-axis twice. All right, so that is this case right here. All right, and this here is the x-axis, and of course this here is the y-axis, and the points where the parabola crosses the x-axis, there's several names for those points. So those 2 points, you can call them the solutions, because it is the solution to the equation when you set the quadratic equal to 0. Okay, you can also call these points the x-intercepts, because it is where the parabola intercepts or crosses the x-axis. Okay, and you can also call those points the zeros. All right, because we get these points by setting the entire equation equal to 0, or y equals 0. All right, and as we know, the equation for the line that goes on the x-axis is y equals 0. Okay, that's this line right here, the x-axis. So all 3 of these terms apply to these 2 points right here. Anyhow, when the discriminant is positive, that means there's 2 solutions, okay? Basically 2 real solutions. All right, and in the second case, when the discriminant is 0, the parabola crosses the x-axis once. Okay, so right here is the point where the parabola crosses the x-axis. All right, and in that case, there's 1 solution. All right, that's when the discriminant equals 0. And finally, the last case, the negative discriminant, the parabola never crosses the x-axis. Okay, so as you can see in the negative case, when b squared minus 4ac is less than 0, the parabola never reaches the x-axis. Okay, so there's no real solutions. All right. Okay, so the reason we have 2 solutions in the first case, when you use the quadratic formula and the square root part is positive, you're going to get plus and minus 2 positive numbers. Okay, so when you add and subtract a positive number, you're going to get 2 different solutions. Okay, when the discriminant equals 0, the part under the square root is 0. All right, and the square root of 0 is just 0. So the plus minus means nothing, because adding 0 and subtracting 0 is the same thing. So you're only getting 1 solution. All right, and in the negative case, you're adding and subtracting the square root of a negative number. Okay, you can't take the square root of a negative number. So those solutions are just imaginary. All right, so really technically there's no real solutions. They're just imaginary. So to sum it up for the discriminant, b squared minus 4ac, if it's positive or greater than 0, you will have two real roots or solutions, and you will have two x-intercepts. Okay, so the parabola will look like this. All right, and you'll get the square root of a positive. All right, if the discriminant equals 0, you'll just get one real root, okay, and one x-intercept. The parabola looks like this, hits the x-axis once, okay, and because it's just plus or minus the square root of 0, the plus or minus does nothing. Okay, and finally, in the last case, when the discriminant is negative or less than 0, no real roots and no x-intercepts. You just get two imaginary roots. Okay, so the parabola never reaches the x-axis. Okay, so on to the actual problems here on Khan Academy. They want to know what is the value of the discriminant of f. All right, so we have our function f of x right here. Okay, remember, our quadratic equation is of the form ax squared plus bx plus c. Okay, so we can find the coefficients by matching them to this equation. Okay, so a is the coefficient with x squared. That's just going to be 4. B is the coefficient with x. That's going to be negative 17. Okay, just watch the signs. And c is the constant term with no x. That's positive 3. So they want us to find the discriminant. This is the formula for the discriminant. All right, so b squared minus 4ac. For b, we have negative 17. And that whole thing gets squared. Okay, make sure you use parentheses. Then minus 4 times a, which we said was positive 4, times c, which we said was positive 3. Okay, I'm going to do this on the calculator. Okay, and I get 241. So make sure when you do the negative 17 squared on the calculator, you use parentheses. All right, because negative 17 squared, the calculator keeps the negative and just squares the 17. Okay, so that's different. But if it's negative 17 times itself, you need to use parentheses. All right, I made a little mistake here. Hold on. So if you type negative 17 squared in the calculator, it will give you negative 289. All right. But if you use the parentheses, it does negative 17 times negative 17, and it will be positive like it should be. All right. So the discriminant is 241. And they ask, how many distinct real number zeros does f have? Let's go back to our chart. Okay, the discriminant was 241, so it's positive. It's greater than 0. That means we have two real roots, or you can say two real solutions. Same thing. Or you can say two real zeros. Same thing. Okay, remember roots, solutions, they're all the same. Zeros, those are all the same. All right, so I just used the formula. Okay, here they ask, is the discriminant of g positive, 0, or negative? All right, so this blue parabola here is the graph of g of x. Okay, clearly we can see the x-axis here. It crosses the x-axis twice. Okay, so those are two real solutions or two x-intercepts. All right, let's check our chart. All right, and we said if it has two real solutions, then the discriminant is positive. Okay, the discriminant is greater than 0. So this looks just like, almost just like the parabola that they gave us. Okay, so it's definitely positive. All right, so since it's positive, just choose that answer, and that's it. Okay, so they want us to find the value of the discriminant. Okay, this is the formula for the discriminant. We just want to get our coefficients. Remember, this quadratic equation is of the form ax squared plus bx plus c. Okay, so a is just going to be 3, b is going to be 12, and c is going to be 5. All right, so b squared is going to be 12 squared. All right, I don't need parentheses because it's already positive. Minus 4 times a, which is 3, times c, which is 5. Okay, I'm going to do this on the calculator. And I got 84. So you just enter that in the box. And we said before, well, I'll go back to the chart anyway, but our discriminant is positive. It's greater than 0. So let's check the chart. How many distinct real zeros does it have? Okay, when the discriminant is greater than 0, it has 2 real roots. All right, and remember before, we said that the roots or solutions, you can also call them zeros. So when it crosses the x-axis twice, that is 2 real solutions or 2 real zeros. Same thing. So for the real number zeros, it's just 2. Okay, here they ask, is the discriminant of f positive, 0, or negative? Okay, so we did one like this already. If it crosses the x-axis twice, the discriminant is definitely positive.